All right, so we have talked about almost everything in relation to solving equations that you're going to need to know. All of the equations we've been dealing with so far are just fairly simple equations. And I think we're going to soon move into graphing. I haven't totally decided which thing I'm going to do next, but it doesn't matter. We'll figure it out. But this is the one last piece that we haven't talked about much. I actually mentioned it Friday, I guess, when we were doing. Remember, we had like 20 minutes of class, and I gave you the boards, and I gave you a few with fractions. And I wanted to give a formal lecture so that you'd actually see this in action, how it works. Because you can make fractions, solving equations with fractions, very difficult and very complicated if you want to. Or you can learn this little approach, which is simple, 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 and it makes it so easy. Amazing. Right? It's so easy. There's no sense in making math hard, right? Make it easy. Make it fun, right? I mean, hard can be fun too, but easy is great. So, okay. So let's say I gave you, I think you probably remember this, but 3.
Should we write this down?
Yes, write this down. If I had 3x over 10 plus 5x, no, so not 5x, plus 5 over 10 equals, let me think for a second, 20 over 10. I'm just making it easy. All right? If you don't know this trick, it might be a little confusing. But there's this great trick that ask yourself, do I have a common denominator on all my fractions?
Yeah.
Yes, I do. So, if I multiply the whole thing by 10, by the denominator, the common denominator, right? It's 10. If I multiply everything by 10, basically, this is what happens. Basically, to multiply this times 10, it's like this. 10 over 1, right? This is 10 over 1. This is 10 over 1. Okay? So I'm going to just remove this. That's kind of what I just did. That's the same as multiplying it times 10. And notice the 10's cross out. Look at that. I just got rid of my denominator. Look how fast that was.
Easy.
Look, the 10's cross out. 10 goes into 10 once. 10 goes into 10 once. And if I have 1 times 1 in the denominator, I don't need it. I don't need a denominator with a 1 in it, right? Right? Like 3 over 1 is the same as 3, right? 5 over 1 is the same as 5. Look, the 10 of the 10 cross out. So all I have left are my numerators. 3x plus 5 equals 20. That's pretty easy. So I have 3x plus 5 equals 20. Whoops. 20. So I subtract my 5, and I have 3x is equal to 15 divided by 3, divided by 3, x is equal to 5. Does that make sense?
Pretty easy.
It's pretty easy, right?
Yeah.
Easy peasy, right? Easy peasy. Now, some of you might have said, oh, but 5/10 is the same as 1/2, right? You'd be making it harder,
Yeah.
just so you know. If you change that to 1/2, and you change that to 2, actually that wouldn't be so hard. But changing that to 1/2 makes it a little harder. It's easier if you have common denominators. Just multiply everything by whatever that denominator number is, and you get rid of all your denominators. You get rid of all your fractions, and suddenly it's really easy. Lucinda.
What do you do when you don't have all? Like, what if you have 3/5 over 5/7?
Right, that's number 2. We'll get there in a second. But I just want to show you a couple more examples of number 1, okay? And I think actually the homework, I think I only gave you stuff related to the number 1, but that doesn't matter because you'll get homework again eventually relating to number 2. Maybe I'll have you write one on there, a couple. Yeah, I'll do that. All right. So So another example might be, let me think. Let's say I had 4x plus 5/3 equals, oh, it doesn't matter, equals 10.
Oh, I know what to do.
All right, so that looks hard. I got that doggone 5/3. I have to subtract 5/3 from both sides. 10 minus 5/3, I don't know what that is. I could figure it out. I'd have to get my common denominators, right? I'd have to do 30 thirds, right?
No, it's easy.
But that's not so bad, but it's not the easiest. Look at this. What is my denominator?
3.
3. Yes, Thorn.
Well, like Jen kind of taught me, Diego, instead of like a way of like doing this. It was like you put a 3 on the top and then 5 in the numerator and the denominator right next to that, and then you would do the same thing to the 10, and then that would equal that, and then it would just be 4x plus 4x equals no whatever that. And then
Almost. So basically, it's the same idea. What I'm doing. The only thing is it wasn't complete. Watch this. What is the denominator?
3.
That's the only fraction. You agree with me? That's the only fraction. There's only one fraction, and the denominator is 3. Watch this. I'm going to multiply everything times the denominator, times the denominator, 3. So I'm going to do this, and then this, and then this. All right, what is 3 times 4?
12.
So 3 times 4x is 12x. All right. 3 times 5/3, the 3's cross out, right?
Yes.
So what do I have?
15.
Plus 5.
Whoa, wait. Oh,
Right? Because look, 3 times the 3, look, that's the same, doing 3 times 5/3 is the same as this. Diego?
Oh, okay.
Right? So look, the 3's crossed out. So it's just 5.
5. Oh.
Right? And then equals, 3 times 10 is 30.
30.
Now we have an easy problem. The minus 5 minus 5. I have 12x is equal to 25 divided by 12 divided by 12. So x is equal to, that's fine, 25 divided by 12. That's fine. Right? Pretty easy, right?
Yeah.
Really easy. Fist to 5, are you getting it? Is it making sense to you? Violet? I know fractions scare you a little bit. How is it? Really? You getting it? I think the place where people will mess up is by doing this, right? Because 3 times this is easy, but 3 times this, in their brain, it's hard. So sometimes it's easier to just, like if I were doing this, 4x plus 5/3 equals 10, right? I would say, okay, I'm going to multiply everything times the denominator, everything times 3. So I'm going to multiply this times 3, and this times 3, and this times 3. Do you see what I mean? That way, you're less likely to make the mistake, right? This, by using the distributive property with fractions, it usually, there's somebody that messes up. Do you see the difference? So this would probably be a safer way to do it. So 3 times 4 is 12x. The 3's cross out. 3 goes into 3 once. 3 goes into 3 once. 5 times 1 is 5. 1 times 1 is 1. 5 over 1 is the same as 5. Right? So you just have your numerator. Equals 30. Right? And then you solve it. Okay. Let's see. I think that's it. So, can I erase?
Yeah.
Number 2.
We just did number 2.
No, we've only done number 1.
No,
We've only done number 1 so far.
Right.
Because that one, the one I just did, we didn't have common denominators, but we only had one fraction, right? We didn't have, does that make sense? We did not have to, Graham, we did not have to convert the whole numbers into fractions. Did you see that? Like, okay, I'll do another one more. So, like 2x minus 4 is equal to 7/5. Right? This is not a fraction. That's not a fraction. I don't have to create common denominators, right? I don't have to put them over 1 and make common denominators. All I have to do is multiply everything by that denominator, and I get rid of that fraction, and I change these numbers, right? So it's going to be times 5, times 5, times 5 over 1. Those cross out. So I have 10x minus 20 is equal to 7. Right? Add 20, I have 10x is equal to 27, divide by 10, x is equal to 27 tenths. Or 2 and 7 tenths, or 2 and 7 tenths, right? All right? You taking notes, Okima? For sure?
Yep.
Okay. All right, so fist to 5. You getting this? Like, it makes sense, right? It's really pretty easy. Really pretty easy once you practice.
Really pretty.
How did I get the what?
5.
Here?
5.
Here? Where? What 5?
5.
Because the denominator. All I care about is what is the number in the denominator. And I just multiply it times 5. I use that number. That's what I multiply everything by, the denominator. Does that make sense? And so you should love this bio. You should absolutely love this because this is the trick to get rid of fractions completely. You can annihilate fractions. Now there's one condition. This is an important condition. It has to be an equation. It has to have an equal sign. I can't just do this to any fraction. I can't just say, oh, here's 2 sevenths. Oh my God, I can change that. I'm going to multiply it times 7 over 1, and it equals 2. 2 sevenths equals 2. Right? That doesn't work. Why? Because it wasn't an equation, right? I'm using the concept that whatever I do to one side, I have to do to the other, the golden rule of algebra, right? So that's why I can do it. I'm changing the value of these things, but I'm doing it to all of them proportionately so that it's still the same, they still equal, right? They're still balanced. I'm adding things to the scale, right? But I'm adding them both, on both sides, right? Does that make sense? So, but if it's not an equation, you can't do this. You can't just turn a fraction into a whole number by, out of the blue like that. Because 2 sevenths does not equal 2. All right. So, all right. Now, what if you have fractions with different denominators? Okay. There's 2 ways to do it, but there's an easy way. So, like, if I gave you, let's see, what if I said 1/2 x plus 2/3 equals 10. All right. Do I have common denominators?
No.
How many fractions do I have? 2. All right, what would be the common denominator if I were going to
6.
create one?
6.
Does everybody agree with that?
Yeah.
That 6 would be your common denominator?
Yeah.
So you don't have to write this down. You use it, you put it in your head. Okay, you say, okay, the lowest common denominator between 2 and 3 is 6. So multiply everything times that, times 6. Watch this. So watch this. And again, do it like this. 6 over 1. 6 over 1, 6. Okay, you with me? So watch what happens. Now we're going to use our upstairs, downstairs, cross-reducing stuff, right? So 2 goes into 2 how many times? Once. 2 goes into 6 how many times?
3 times.
3 times. 3 goes into 3 once. 3 goes into 6? Twice. Okay, and then that, we're fine. So now look, I have 3 times 1 over 1. So 3x. Do you see that? I have 3x. 3 times 1 is 3. Times x is 3x. 1 over 1, do I need that? Do I need to put it over 1?
No.
No, because 3x over 1 is the same as 3x. Right? Plus, now look, I have 2 times 2 over 1. That's 4. equals 60. Look at that. In one move, I got rid of my fractions. One move. It is brilliant. This is such a great trick. I'm not multiplying times the reciprocal. You see the difference, right?
Yeah.
I'm multiplying just by that denominator. Right? So make sure this is in your notes, okay? So what do I do now? Well, what's the next step?
-4.
-4. -4. I've got 3x is equal to 56. 320, it doesn't go in evenly, so it doesn't matter. Divide by 3, divide by 3. X is equal to 56 thirds. That's fine for now. Yes. Okay, or,
Wouldn't it be 19 possibly?
well, 20 would be 60, so 19, oh, maybe you're right. 3 goes into that once, carry the 2, 26.
No, it wouldn't be right.
No.
Yeah.
It wouldn't be 9, so it'd be 18 and like 2/3 or something like that. I don't know, something like that. Is that right? Did I do that right?
Yeah.
It's 5. So,
18 times 3 is,
oh yeah, 824. That's right.
is that right? Whatever. So,
Take your.
yeah, whatever. You know, I'm a math.
Whatever. It's
Whatever.
math.
You know, it's close enough.
It's close enough.
Right.
Close enough.
All right, so let's, can I erase all this now?
Yeah.
Now that you've got it in your notes?
Yes. No.
What did you say no to? Which part? Okay, I'm just erasing upstairs. Okay?
Oh, upstairs, downstairs, Gary.
Okay.
Get it?
Yeah. All right. All right, so let's try another one like number 2, okay? Let's try another one. And this time, okay, let's try this one. Oh, this will be good. All right, so let's say we have 2x over 4, over 3 plus 5/6 equals 7/12. Ooh. Now this is Violet's favorite kind of a problem, I can tell you right now. She would love to do this one, right? Because she loves fractions. But if on a certain given day she decides she doesn't like fractions, she knows that she can just figure out how many fractions are there?
3.
All right. What are the denominators? 3, 6, and 12. Are they common denominators?
Yeah.
I know. Wait, what?
What are they common denominators?
Yeah.
Yeah.
That's common as a number.
They're all different. What is the lowest common denominator?
12.
Okay, 12. Does everybody agree with me?
Yeah.
Yeah.
12. Everything in there goes into 12, right?
Yes.
All right. So we're going to multiply everything times 12 over 1. Everything times 12 over 1. Everything times 12 over 1. And you're going to see, well, I'll let you write it down first. Now we're going to use upstairs, downstairs, cross-reducing stuff, right? 3 goes into 3.
Once.
3 goes into 12.
4.
4 times. Okay. I can't go further with a 1, right? Once there's a 1, I can't do anything there.
6 goes.
But 6 goes into 6 once.
Once. Twice.
6 goes into 12 twice. All right. Look at that. 12 goes into 12 once. 12 goes into 12 once. The 12 just totally crossed out there. So now, you with me so far? Does that make sense?
Yeah.
All right. So now I just do my simple multiply. 4 times 2x. That's 8x. Look, all I have is underneath is 1s. I don't need it. Plus, 5 times 2 is 10. I just have 1s underneath. I don't need them. Equals 7. Look, the 12 crossed out completely. So now I subtract 10. Subtract 10. And 8x is equal to -3. Okay, divide by 8. Divide by 8. X is equal to -3/8. Fractions are cool. It's okay to have a fraction as an answer.
Fraction.
Totally fine.
Thanks, Gary.
Does that make sense?
Yeah.
All right. So homework tonight is Have I collected everybody's homework?
You made
Did I collect yours? I mean, your test? Did I get your test back? I did, you gave it back to me? Okay. You did? Is that what you did for sure? You gave me your test? Alright, let me
Wait,
cross
is
this
this
out.
that thing?